Hi everyone, my name is Joshua and welcome to Northern Solar. So here we are at the end of July. It's been a roller coaster of a month really when it comes to production. So we're going to look back at the figures, see how we've got on with our solar panels and battery system. Try and answer the question, are solar panels worth it? Before I jump into the figures for the July, I just want to answer a few questions that people have been asking on the comments in the last few videos. One of the more common things that people are commenting is that I have a lot of excess energy from our system during these summer months and I should probably get some sort of water tank heater to use that excess energy as much as possible rather than exporting back to the grid. This is definitely something we're looking into because we do have a lot of excess, and next year when we do a bit of renovation at the house, we are planning to remove the gas combi boiler and have a hot water tank which then can take the excess energy and use the immersion heater in that tank to use the solar power to heat the hot water to help reduce our gas bill going forward. So here in the UK during July we had a bit of a heat wave, as you probably read about. We got up to about 38 degrees here in Cheshire and people were asking questions about how the battery and the inverter coped being in the loft. So yeah, I was monitoring that situation pretty carefully, and the highest the battery temperature got to was 39.9 degrees C, which is pretty high, but it's well within the acceptable limits of the battery's technology, and that gives me a lot of confidence that even in a heat wave the battery system is absolutely fine. Another really common question that I get asked is about the spreadsheet that I make to calculate the return on investment, how long it takes to pay for itself. I made more of a video about it and I'll put a link up here if you want to see that one. But really, yeah, the assumptions in there are quite general. It's hard to be very specific when it comes to exactly how long things are going to take to pay back. So my spreadsheet's by no means perfect. It's a pretty simplistic view of how things might pan out. It's really hard to be too accurate with this sort of thing. I'm pretty confident that the assumptions that I've made do reflect roughly what we're hoping to see in the next few years. And I can always update things as I go to see how our cost savings and our assumptions around production reflect in real life what's happened over the first year, and then maybe make a more accurate model for payback. But realistically, it's hard to see a scenario where the panels don't pay for themselves, especially given the price cap increase that's expected this autumn. So we'll see how it goes from there. Right, so that's all out of the way. The reason why everyone's here, let's look at July's figures. It's been a bit of a roller coaster of a month. We've had heat waves and storms in the UK. So as you can see, the days varied from around 50 kilowatt hours at this part of the month, all the way down to like 10, 11, 12 kilowatt hours at these parts of the month. I was a bit surprised by this, to be honest. I wasn't expecting days with such heavy cloud in July. So our total production for the month of July was 952 kilowatt hours. That's an average of 30.7 kilowatt hours per day, with a highest of 51.2 on the 10th and a lowest of 10.8 on the 28th. Before we look into the production, consumption, financials and everything, I just wanted to show you two graphs, one from a sunny day and one from a cloudy day, to give you an idea of what we've produced across a whole day. So here we are, this is the graph from the 10th of July, which was our highest producing day of the month. So the day started around 5:15 when the panels first turned on, and then it gradually increases. So by 9 o'clock we were already producing 3.3 kilowatts. And then you can see you get a really nice peak around lunchtime, which comes at 5.38 kilowatts. Now this is lower than our 6 kilowatt inverter limit, and I think that's due to the high temperatures making the panels slightly less efficient at this time of year. We have had days in the past where the peak has been around 6 kilowatts when the temperature is slightly lower. And as you can see, the afternoon follows the same pattern down the other side, and then it tails off pretty quickly in the evening, and then eventually sun sets and we finish the day around 9 PM. So let's compare that to our worst day of the month, which was the 28th of July. So again, the day starts at around about the same time, 5:30, 5:45, the panels start lighting up. But then by 9 o'clock, we're only at 1.5 kilowatts. And then our peak, after a lovely cloudy morning, our peak reached just over 2 kilowatts briefly around lunchtime, and then another very cloudy afternoon, and you can see the production coming all the way back down, and then pretty much tailed off, and again by 8 o'clock, back to zero. So hopefully that should give you a pretty good idea of what a cloudy day looks like versus what a sunny day looks like in terms of production. So looking at the production and consumption in our house this month, so as I mentioned, we generated 952 kilowatt hours during the month of July. According to our export meter, we exported 517 kilowatt hours back to the grid. That gives us a total solar consumption for July of 435 kilowatt hours. According to our meter, our grid consumption was 90.4 kilowatt hours, 4.4 of which was during the peak hours, and 86 was during our overnight off-peak consumption mostly for charging the car. So if you add our solar consumption and our grid consumption together, you get 525.4 units for the month of July. Moving on to the breakdown of our solar, you can see the export versus consumption was 54% exported and 45% consumed. This is following a similar pattern to the last couple of months due to the extremely sunny weather we've been having. And if you look at the total usage breakdown between the solar and the grid, again, very similar to last month. 82.8% usage was from solar and 17.2% was from the grid. So moving on to financials, our standing charge for the month of July was £14.78. Our total grid usage cost us £10.20, which gives us a complete electricity cost of £24.98. Our 517 kilowatt hours exported to the grid earned us £29.73, giving us a net electricity cost of £4.75. The cost of our total consumption if we did not have solar panels would have been £144.94, which means overall our monthly savings for July were £149.68, almost exactly the same as June. So now that we've had 4 months of figures, you can see the cumulative savings are beginning to add up. We're at £519 already. So another good set of figures for July. Again, around about £150 saved this month. So again, if we're answering the question, are solar panels worth it? We've still got to say, for us here, yes, definitely yes. I just wanted to say a really big thank you again to everyone who's commented and asked questions. It's been really interesting hearing about everyone else's systems and how things work in other parts of the world. But that's it for now. So as ever, thanks very much for watching and see you next time.